Hi, Namaskar. So let us start with FPGA trainings. What we'll be doing is we'll try to design FPGA based design based on Xilinx FPGAs. Okay. So I have a ready solution with XC7S50-2FTZB 196C. This is the part number. This is a very good device. However, first of all, we will try to understand how to select a part and what are the things that we should take care while designing the FPGA. All right. So I'll directly take you to the FPGA website. You can go to xilinx.com or amd.com. Anything is fine. AMD has acquired Xilinx. So once you reach to AMD website home page, you can go to product page. In the products, you will see adaptive SoCs and FPGAs. These are system on chips and FPGAs, right? So once you click that, you have an option of FPGA portfolio. All right. Once we go to FPGA portfolio, you will see almost all the devices that is available with Xilinx. So when we come here, I will suggest you like we have lot of components that is there with Xilinx AMD. However, you can directly go to product selection guides and that will give you a very good information of comparison between different FPGAs. So once you reach here, you can also see before going to there, you can also see that they have reached up to 16 nanometers. Earlier it was 20 nanometers and then we have 28 nanometers. So our main focus will be working on 28 nanometers device, and this is the lowest in Spartan 7. As you go on rightwards like RTX, Kintex or VTEX, so the complexity and the performance increases. Okay, so what we'll do is our main focus will be working on a Spartan 7. All right, so we'll select a device which is based on a Spartan 7 series. A very good device. It can run up to around 2035 minimum. That is claimed by AMD. So you don't have to worry about your design. It can easily work up to 2035. And I can assure you from my side that it can definitely go as long as like 2040 or 45 as well, based on the market scenario. Good. So let us proceed to product selection guide. So once you open a product selection guide, what will happen is, see, these are the product selection guide. You can see 7 series, cost optimized portfolio, ultra scale plus. So our main focus is 7 series. All right. So once you open the 7 series device, you can download it or otherwise leave it. So you can see we have Spartan, RTX, Kintex and VTEX. Okay. Let me just open the downloaded version. I have already downloaded it for you. So let us try to understand what are the things that we should take care while selecting a device. So while selecting a device, first of all, we need to find out what is the part number that we'll select based on the resources that we need. So these are the logic cells and slices and CLBs. Okay. So based on this, if I tell you, you can go ahead directly with I mean, if you have very small number of requirements like 100 IOs or something, okay, and you don't need a lot of logic cells and all, then you can simply take up the lowest series XC7S6, and I will give you a design based on this as well in our upcoming tutorials. But my focus will be going in the mid range, which will be XC7S50. Okay, so this is the device that is of my prime focus. Okay, and in this you can see you have lot of logic cells which can meet any requirements. We have good number of slices as well, CLBs, flip-flops as well, and we have these are the maximum values, so you don't reach into that. XC7S50 has different portfolios that I'll tell you later. So our main focus is to select this device, and we will not go with maximum IOs, that is 250. We will take up mm, the package which will be FTZB 196, which has 100 IOs. Okay, so these are our prime focus. Okay, so based on this, I will give you the part number, which will be XC7S50 dash. This is the like commercial temperatures and their speed grades. So speed grades is, I mean, dash 1 is the lowest grade, slowest one. Dash 2 is highest, I mean more, or highest grade or highest speed. Dash 1 L is low power, so if you want to utilize a low power performance, you can take up -1 L. Okay, so what I'll do is I'll go ahead with dash 2, so there should not be any problem later on. And then FTZB 196 C, I will go ahead with consumer temperature, commercial temperature range. Okay, if you want, you can go ahead with industrial temperature range as well. So if you replace this C with I, this will be more than enough. Okay, so this is the device that we'll be selecting on. Okay, more things if you want to see, you can go ahead. These are other portfolios. This I told you about a Spartan 7 series. Okay, you have other ones like RTX that I'm not going to explain you now, Kintex and Vtex. Okay, so these are, I will not be explaining you now. If you want to order your device, so just now I gave you one part number based on this only. So what you have to do is, let me create a part number for you. It will help you to understand how industries works basically. So all the students that you are there here, you must understand how to write a part number from the ordering information, so that you can be very sure what device you are selecting on. Okay, so XC, that is commercial Xilinx generation, is 7. Okay, so XC7 is your generation, S is your family name. Okay, then number of logic cell. So logic cell, as you could have seen, that it was 6 or 15 or 25 or 50. So I'll take up S750. Then dash. Speed grade is slowest, low power, and mid range. So mid range is -2, so I'll take up -2. Okay, then these are the package types. So if you want to have like I mean wire bound, or I mean these you don't have to worry about. I'm going to select a device which is like having the highest pitch, so I'll take up FT. And then Z is with ROHS, so I'll definitely select G. And package designator, so F FTZ, I will take up B. Okay, it is not shown here. I'll tell you, I mean, what are the different documents that you need to download. Okay, so based on that, I'm going to take you FTZB. There you will get it like easily, and then 196, and then C. Okay, so this is the device that we have found out. Okay, let us talk about like a digital signal processing matrix. So you can see you have DSP slices counts based on the device informations. So if you take XC7S50, you have what, like 120 slices, and it can go up to, if you have a Spartan 7, speed grades are what? If you have a speed grade 1, then maximum frequency is 464. If you have a speed grade 2, then maximum speed is 550 megahertz. All right. So we'll take up 2. So based on this, we have selected. If you want to go ahead with very high number of DSP slices, then you can go ahead other ones like XC7, VX. So you can see these are the Spartans, okay, which is S, okay. XC7S, S means Spartans, okay. Then XC7A, A is RTX series. So RTX portfolio is this one. So directly you can see RTX is having higher performance or higher like resources compared to Spartans. If you go ahead with Kintex is even much higher, and then Vtex is much more higher, the highest like performance and everything. All right. Now, number of block RAMs matrix that you can see, the lowest one is XC7S6, so 180 block RAM capacity and 180 MB is there. If you see this one, which is our interest, XC7S50, that is 2700. Okay. Next is high speed serial transceivers. So if you see, you don't have serial transceivers in your XC7S series. So if you want to go ahead with that, you have to go ahead with automotive applications or like RTX series. So RTX series, if you want to utilize series transceivers, you can go ahead with RTX one. It will be directly compatible XC7A20T, 7A50T. So once we design with XC7S50, our main, focus is extending the same design with other devices as well. So a lot of devices are there which are compatible to this. Okay. All right. So all these informations you are there. I'm going to tell you directly what is the IO counts and bandwidth. So IO count, you can see XC7S50 is having 250 maximum. This is maximum number. Okay, so I will be working with 100 IO pin counts. Okay, now the best thing that I want to tell you about this particular selection guide is it has all the documents that you need to work with this particular FPGA. Okay, so if you want to go ahead with a 7 series, okay, like a Spartan 7, then datasheet 180 is the best a thing that you can take care of. So I will just download it for you and show it that what are the things that you can do with that particular device. Okay. So let us download and open this device. As you can see, you have just 19-page document and it is having almost every information. Like you have the Spartan 7 family here, and all the other families are there as well. Okay, why I have opened this particular things is you have family comparison in one ahead. Okay, I mean one place. So like a Spartan 7, if you see logic cells, you have 102 kilo bytes and it has 215 and this, right? You have block RAMs, which is the lowest one here, and then DSP slicer and all the other things as well. Okay, so our main focus is Spartan 7. Okay, then this is the lowest cost and good performance for any application that we require. Okay, the maximum number of IO pins are like 400, so I will not be going ahead with that. I will be going ahead with 196 pins. Okay, now only Spartan 7 summary. If you see the Spartan 7 summary, let us talk about XC7S50. So XC7S50 is having this particular number of logic cells, slices, and DSP slices. So all the, these are the criteria for selecting your FPGA. The more number of times you read this particular informations, more confidence you will have with your FPGA that you have selected, and it will be easier later on for you to work on. Okay, if you want to really work very easily, very freely, there is no need to think later on after your selection. You just give 1 or 2 days time to select your FPGA and do a very deep understanding about each and every resource that is available with that particular device. Okay. For students who are starting, you guys can go ahead with XC7S 6 series as well. Okay, because those are very low number of IO pins and they are very good as well. Okay. Next, the beauty that you can see is, let us talk about XC7S50. Okay, so XC7S50, you can see you have FTZB 196. This is 15 cross 15 device and pitch is 1 Okay, now If you want to later reduce the number of logic cells, you can easily go ahead here, because this is also compatible, this is also compatible. If you want to go ahead with even lower cost, you can go ahead with here. Okay, and you can go to XC7S6 as well. So as you can see, from XC7S6 and XC7S50, all these four devices are compatible to each other. Okay, so that's the main reason I have selected this particular device for, like port compatibility and like migration availability. All right. That's all. So this is the main thing that I wanted to uh, give you an introduction about selecting an FPGA. If you do have any questions, you can like put there in the comments. From next onwards, what we'll be doing is we'll be going on FPGA architecture development. Okay, like what are the things that we need to take care while designing an FPGA. Okay, for example, I'll give you a introduction about that, like what is my power supply scheme, what is my programming through like JTAG or any other scenarios, how to assign IOs. Okay, so all these one by one we will see in each classes. Okay, all right guys, thank you so much for your availability. All right, bye.